Hello everyone, so welcome to this video tutorial that discusses homogeneous differential equations. So from our previous topic, we have discussed variable separable differential equations where we can simply put all the terms with x beside dx and put all the terms with y beside dy and then just do direct integration. But we have a more complex differential equation forms wherein we cannot simply use the steps of solving variable separable. So we have this next type, the homogeneous differential equations. So a differential equation of this form, as you can see from the screen, is said to be homogeneous if functions m and functions n are homogeneous functions of the same degree. What does that mean? Homogeneous functions of the same degree. So now, how do we know that they are homogeneous? So we will do the testing of the homogeneity of the function. A function f of x and y is homogeneous of the nth degree if the function of kx and ky can be equal to k raised to n times the function of x and y. So what does that mean? You have here the original function f of x and y, and if you are going to substitute all the x with kx and all the y with ky, and after doing that you can factor out your k raised to n, and the remaining would be the original equation, then your original equation is a homogeneous function of the nth degree, the exponent of your k. So given that we have found out that the differential function or differential equation has your functions m and n, which are both homogeneous function of the same degree, then what would be the next step to solve for the solution of that homogeneous differential equation? So we have here the steps in solving homogeneous differential equations. First, you test the homogeneity of the given differential equation, which was discussed a while ago. And after that, let's go back first to the original, or to the differential equation of this form. So we have here the function that is put beside dx is our m function, and the function that is put beside our dy is the n function. You have to compare these functions m and n. And if m, going back to the steps, if m is simpler than n, then you let x be equal to vy. And differentiating this equation, we have dx is equal to v dy plus y dv. You substitute these equations to your m dx plus n dy differential equation. But if n is simpler than m, you will substitute, you will let y be equal to vx, so that differentiating this equation, you will get dy is equal to v dx plus x dv. Both of these equations you substitute to your original homogeneous differential equation. After doing that, you choose step 2 or step 3. After doing that, simplify the equation and solve it like how variable separable differential equation is solved. So this means that after substituting either this step or this step to your given DE, you simplify it, and after that, it will result to a variable separable differential equation. And of course, you have already known how to solve VSDE. So now, given that you have solved for the general solution, which is in terms of x and v or y and v, then you have to restore, final step, you have to restore the original variables by substitution.